All right, welcome to the deep dive, everyone. You know the drill. We're all about getting to the core of a topic fast, giving you the knowledge you need without any fluff. So today, based on what you wanted to learn more about, we're diving deep into crew rotations on the International Space Station, the ISS.
Yeah, fascinating stuff.
And what we really want to do for you specifically is sort of unpack how these rotations actually work. We all see the headlines about the amazing discoveries and achievements, which are obviously a huge part of it.
Absolutely.
But we're also going to look at some of the challenges, those aspects that maybe don't get as much attention. Your sources actually cover a pretty impressive range. We've got cutting-edge science, the whole international collaboration angle, the logistical headaches of getting people to and from the station, even some reports on astronauts being stranded up there, which is
Mhm.
kind of a scary thought.
It definitely adds a layer of complexity, to the
Yeah.
whole endeavor. And it's not just technical issues either. We've also got the impact of global politics, the physical strain on the station itself. Those are really important pieces of the puzzle, too.
Definitely. So to start, let's maybe lay out some of the more well-known successes. I mean, the ISS is often called this like floating laboratory, right?
Yeah, it's an incredible platform for experiments that you just can't replicate down here on Earth. I mean, think about it. Microgravity, it's a completely unique environment.
Right. Like I was reading about this research they're doing on bone density loss, which could potentially lead to better treatments for osteoporosis back on Earth. That's pretty remarkable.
Yeah, it's a great example. And it's not just medical stuff either. They're doing all sorts of research in biology, physics, you name it.
It's really pushing the boundaries. And another thing that really stands out from looking at all these sources is the level of international cooperation involved. You've got NASA, Roscosmos, the European Space Agency, Japan, Canada. It's pretty mind-blowing when you think about it.
Yeah, it really is. Especially when you consider all the political tensions we have going on down here, right?
Exactly. Like up there in space, these countries are working together towards a common goal. That's got to be inspiring for a lot of people, I think. And it kind of points to a future where space exploration is this truly global effort.
Absolutely. And all this collaboration is laying the groundwork for even more ambitious missions down the road, like, getting humans back to the moon, maybe even Mars someday. I mean, the ISS is basically a testing ground for figuring out how humans can live and work in space for extended periods.
Which is super important if we're talking about, traveling further and staying longer. I mean, the data they're collecting on the ISS about like the effects of long duration spaceflight on the human body, that's going to be crucial for planning those future missions.
Absolutely crucial. And, something else that's really exciting is the role of private companies. SpaceX, Boeing, they're becoming major players in space exploration now. I know you were interested in that aspect.
Oh, yeah, definitely. Like with SpaceX's reusable rockets, the cost of getting to space is coming down significantly. That opens up a lot of possibilities.
For sure. It's becoming more accessible, which
Mhm.
is, pretty incredible. And we're also seeing some fascinating tech advancements on the station itself. Things like AI and automation being used for maintenance.
Right, like those self-driving cars, but for space. That's pretty wild to think about.
It is. And it's all part of this gradual move towards creating more self-sufficient spacecraft.
Yeah,
You know, the kind we'll need for those long-haul journeys to Mars and beyond.
makes sense. But okay, let's shift gears a bit. We've talked about all the amazing stuff happening, but, like we said, there are also some pretty serious challenges to consider.
Yeah, definitely. Some of your sources touched on this. I mean, the risks are very real, and sometimes they're kind of overlooked in all the excitement.
Right. And one of the biggest ones, it seems, is the possibility of astronauts being stranded in space due to like technical malfunctions or other unforeseen problems.
Absolutely. I mean,
Right.
you've got this incredibly complex system orbiting hundreds of miles above Earth. Things are going to go wrong sometimes, right?
Definitely. And even with the best backup plans, there's always that element of uncertainty. I mean, I was reading about this one instance where some astronauts ended up being stuck on the ISS for 9 months, nine
Yeah.
months, because of some technical issues that delayed their return.
Yeah, that's definitely a worst case scenario.
Yeah.
And it highlights the kind of psychological resilience that astronauts need to have. I mean, you're so far from home in this confined environment, constantly dealing with these high stakes situations. The mental and emotional toll can be pretty substantial.
Oh, yeah. Fatigue, stress, the constant feeling of isolation. Those are all things astronauts have to grapple with on a daily basis. And it's not like they can just pop out for a walk to clear their heads, right?
Exactly. Yeah. And on top of all that, you've got the whole geopolitical situation to consider. I mean, some of the news articles you shared really highlight how tensions down here on Earth can spill over into space.
Yeah, it's a constant concern, especially with the war in Ukraine and, Russia making those statements about potentially withdrawing from the ISS partnership. That's got to be creating a lot of uncertainty and tension.
Right. And it raises questions about funding, about the future of the ISS itself.
Exactly. I mean, it's already over 25 years old and it's showing its age. I was reading about those cracks and air leaks they've been finding. That's pretty concerning.
It is. And NASA has already announced plans to retire the ISS by 2030, you know?
Right. So even without all the political stuff, the station itself is facing some major challenges. I mean, it's kind of like an old car, right? At some point, it just becomes too expensive and risky to keep fixing it up.
Yeah, that's a good analogy. And beyond the structural issues, there are also the risks to the astronauts' health.
Yeah.
I mean, you shared those medical reports. Spending prolonged periods in zero gravity, it takes a toll on the body.
Oh, for sure. Like bone density loss, muscle atrophy, not to mention the increased risk of cancer and other health problems due to constant exposure to radiation.
Exactly. And then there's the whole psychological aspect.
Hmm.
Sleep disruption, the isolation from friends and family, all that can really impact their mental well-being. It's a lot to deal with.
It really is. And we haven't even talked about space debris yet. That's a whole other layer of risk.
Right. And a growing one. You know, the ISS has had to perform all these avoidance maneuvers to dodge bits of space junk whizzing around. It's like
Yeah.
playing cosmic dodgeball up there.
Yeah, it's kind of crazy when you think about it. And the more stuff we put into space, the bigger the problem becomes. I mean, one major collision could potentially force an emergency evacuation of the entire station.
Absolutely. It's a very real threat.
So, okay, when we step back and look at the big picture, what do we see? We see this amazing testament to human ingenuity and international collaboration. We see these incredible scientific advancements and this stepping stone to future exploration. But we also see these really substantial risks and challenges.
You've got it. And, you know, I think what your diverse set of sources really highlights is that we can't just focus on the exciting stuff. We need to understand these underlying challenges as well if we want to create a sustainable future for humans in space.
Absolutely. So, for everyone listening, here's something to ponder. We've looked at both sides of the coin, the triumphs and the dangers. So, in your opinion, what's the single biggest hurdle facing long term human presence in space? Think about it. Maybe we'll tackle that very question in our next deep dive. Until then, thanks for listening.